Welcome to a lesson with Dr. Powell. Let's take a look at how we can guess what degree a polynomial has just by its graph. First of all, end behavior says a lot, because if the end behavior seems to be opposite, like this, we know it's going to be an odd degree. If the end behavior seems to be like this or this, then we think even degree. Okay, and so that's quite helpful. Also, we kind of think, what would happen if certain parts of the graph would shift around, like this one right here? And maybe that just goes down. So that's kind of the end behavior. Maybe that's all of the bounces that we have. Well, and maybe right now, maybe this is the x-axis. Notice it only has one x-intercept or 1, 0. Well, what would happen to different coefficients if you changed their values and ended up kind of shifting these humps like up or down in some way? What could happen is this hump right here could be pulled down. This hump could be pulled up, and this hump could be pulled up. And the maximum way that could happen, let's see, at least in this situation from what we can see, it seems like this hump could be pulled down. This hump could be pulled up, and this hump right here could be potentially pulled upward as well. Now let's count how many zeros we have. 1, 2, 3, 4, 5, 6, 7. Okay, so it looks like, at least minimally, we should expect the original polynomial that we drew to have no less than 7 zeros. And we also want it to be odd. So we can think in our minds, just guessing, that the degree of this particular polynomial just from its graph is either 7 or 9, 11, etc., going up this way. Of course, in these kind of fiddling around with humps going up and down, these could potentially curve like cubes maybe, but also we have the option of some of the zeros being complex or meaning or imaginary or something. And when that happens, you don't even see anything. Okay, or you sometimes, or maybe you don't, maybe that's not noticeable what's going on. But we know that at least the polynomial has a degree 7 and it would go up from there. So that would be our guess, and kind of just looking at that. Another thing we can see is just count the number of humps. 1, 2, 3, 4, or turning points. Okay, 1 turning point, 2 turning points, 3, 4, 5, 6. Notice how 7 was just one more, and usually that'll be true. It kind of has to do with when you count the turning points and you add 1, that's actually, you actually get these kind of number of potential crossings. Hence, you kind of get the degree, because you think of this being factored and multiplied out, you would have a degree 7. So kind of a thought in that case. Let's look at a couple examples with these things in mind. What if we had something that looks like this? What kind of degrees could we guess that this polynomial would have? Well, let's just count the turning points. 1, 2, 3, 4, 5. Add 1, we could think it has at minimum maybe degree 6, which makes sense because it's like end behavior down, down. So we think maybe at minimum degree 6, and it could just go up from there, but it must be even. Let's look at another one. What if we had something that looks like this? So we count 1, 2, 3, 4. And then we add 1. So we say it has maybe at minimum degree degree 5, but it could be any odd number up from there, 5, 7, 9, and so forth. Thanks for watching.